Hello friends, in this session we will see some examples on Nyquist Stability Criteria. Let us begin. So if you see here, the first example is, let us take GH equal to S plus 2 upon S plus 1 into S minus 1, right? Yes. So the first step is what? First step is what? To plot the polar plot. That is the first step. Let me write down. Right, see, the first step is to plot the polar plot, then second is what? To plot the mirror image, third is what? To draw semicircles if there are any, right? And then we need to check for encirclements. Is that correct? Yes. So let us start. This is going to be real axis of GH plane, and this is going to be imaginary axis of GH plane. Is that right? Yes. Now see here, the plot for this will be somehow like this. We have seen same example earlier as well, and the polar plot is something like this. It will start at 2, and it will end at 0, right? This is the polar plot. Step 1. Is that correct? Yes. If you see, this becomes your omega equal to 0, and if you see, this becomes your omega equal to infinity. Is that right? Yes. Now step 2 is what? Mirror image. Mirror image of the polar plot. So the mirror image of the polar plot goes like this, because it has to be about the real axis of GH. So this becomes this way. This is going to be the mirror image. So this is the second step. Is that correct? Yes. If you think of this third step is what? Semicircles. If you remember, we have to draw semicircles, infinite radius semicircles, only when you have either poles or zeros at origin. Are there any? No, which means there will be no semicircles in this case. Is that correct? Yes. Now see here, where will be, now we are interested in what? Encirclements, right? Yes. Yes. So we want encirclements now. Now see, if you find here that 2 is here, right? Which means, or I should say minus 2, this is minus 2, right? So where has to be minus 1 will be inside. Is that correct? Yes, definitely. Now see, this is the important thing. I will tell you what. See, how to check the encirclements. That is the question, right? So small trick is there. What is that trick? The trick is, you please project this minus 1 down, right? Yes, done. Now if you see, now you have to check or observe the number of intersections to this particular projection line. There are how many number of intersection to it, and in what direction. So if you observe this particular blue which is there, you have only one intersection with it, and that too in anti-clockwise direction. Which means anti-clockwise indicates what? It is going to be positive, which means encirclements n is equal to what? Positive, which is nothing but plus 1. Encirclements n is plus 1, right? Yes. Now we want to understand the stability. So for stability, we know n is equal to OLP plus minus CLP plus, right? So if you see here, this is going to be plus 1, right? How much is OLP plus? OLP plus, if you see, it is nothing but what? Open loop pole at RH. So there is one open loop pole at RH, which is this one. So which means here we have 1, right? Then what? You are going to have this minus sign, and yes, closed loop poles at RH. So this is going to be closed loop poles at RH, which is plus. So if you see, how much is CL plus? CLP plus? CLP plus is going to be how much? It is going to be 0, because this 1 and 1 will get cancelled. This means that even if my open loop system is unstable, my closed loop system is stable. This is what we have seen. Is that correct? So this is all about the Nyquist stability criteria example. We will take some more examples. Let us see them. See here. Yes. Step number 1 is what? To find the polar plot. Step 2 is what? It's mirror image, right? Step 3 is what? Semicircles. Step 4 is what? Step 4 is what? Encirclements. That's it. That's all, right? So the first step, let us start with that. I will try to show you the thing. I will try to show you the 4-step way to draw the plot, right? Let us see that. So if you just observe, the first step is to do this GH of j omega, right? Which is nothing but j omega plus 2, means you have to just replace s by j omega. So it becomes what? J omega plus 2 upon j omega plus 1 into j omega minus 4. Is that right? Yes. Now the step 1. Step 1 is what? S1. Step 1 is what? To find m0 and m infinity. What is m0? It is nothing but magnitude. So for that I need to have magnitude as well as angle. So if you think of m, how much is that magnitude? Magnitude is going to be what? If you see, this is the real part and this is the imaginary part, right? So it becomes under root of, real part is what? Real part is 2, so it becomes, or we can say omega squared plus 4, right? Divided by what you have is again under root of, if you see, real part square plus imaginary part square, so it becomes omega squared plus 1. Again, if you see under root of real part square plus imaginary part square, so it is 4 squared, and this is omega squared. So if you see, you get omega squared plus 16. Is that correct? Yes. So if you try to find m0 from this, how much is that m0? M0 is going to be, you have to place m when omega equal to 0. So if you see, you get, if you place omega equal to 0 in this equation of the magnitude, you get 0 plus 4 upon under root of 0 plus 1 into under root of 0 plus 16, right? Which is equal to what here? Yes, it is going to be under root of 4, which is nothing but 2, divided by under root of 16, which is 4, so you get half. This is going to be m0. Is that right? Now what about m infinity? What about m infinity? M infinity is what? Magnitude at omega equal to infinity. How do you do that? Yes, so if you check out for this one, in order to check, if you see, the denominator has more weight. Why? Because you have these two poles. If you don't understand it, we can do the same example. What we can do is we can take omega out from the numerator as well as from the denominator. So from here, so from numerator, if you see, if I try to take that omega out, what do I get? I get omega into under root of 1 plus 4 by omega square. Is that right? We have already done these things, right? Again, so if I divide this, then again, yes, 1 omega square coming out from here, and again omega square coming out of the square root, it will become omega. So I will have 1 omega for this one, which is omega into under root of 1 plus 1 by omega squared, right? Into, I will again have omega into under root of 1 plus 16 by omega squared. Is that correct? Yes. Now if I see, omega gets cancelled. Now if I replace omega infinity, then what happens is, here this becomes infinity, so this total term becomes 0, right? Similarly, but here you have this infinity, right? And this is nothing but 1 plus 0. 1 plus 0 is equal to 1, so you get 1 by infinity, which is nothing but equal to 0, right? Now step 2 is what? Phase angles, phi 0 and phi infinity. For that I need phase. Okay, so how much is the phase? Phi is going to be what? Phi is going to be nothing but tan inverse of omega by 2, right? Because if you see, this is the imaginary part and this is the real part, so that is nothing but it. Now next is what? Minus tan inverse of, again 1 by, again omega by 4. Is that right? Yes. Minus, so tan inverse of omega, right? It is not omega by 4, it is tan inverse of omega, plus minus 180 degrees plus tan inverse of omega by 4, right? Why? Because if you see this particular one, if you see, real part is negative, real part is negative. If real part is negative and imaginary part is positive, it means it is lying in which quadrant? Real part is negative and Imaginary part is, this is real part which is negative, and imaginary part is positive, so it is lying in the second quadrant. So for second quadrant, this is what is the angle we have already seen, right? Yes, so this becomes your phase. Now I am interested in phi 0 and phi infinity. So if you check out, it becomes, step 2 is what? To find phi 0. What is phi 0? Phi 0 is nothing but phi at omega equal to 0. So what do you get here? You get tan inverse of 0 minus tan inverse of 0 minus 180 degrees plus tan inverse of 0, right? So if you see, all are 0 0 0, all are gone, which means it is going to be minus 180 degrees is only remaining. This is going to be the answer. Is that correct? Yes. Now next is what? Next is what? You have to find phi of infinity. What is phi infinity? Phase at omega equal to infinity. So if I place omega as infinity in that angle equation, in this angle equation, what do I get is, right? So it is equal to what? If we check out, these two will get cancelled, right? And we get minus 180 degrees, and this one tan inverse of infinity is nothing but 90 degrees, so you get plus 90 degrees. So this becomes minus 90 degrees, right? Now if you observe what you have, it has to be the observation at first. If you see, you are having one pole on the right half of S plane, right? This means that the four step method cannot be applied completely, right? But step 1 and step 2 can be done. So yes, step 1 and step 2 has been done. But now we are interested in what is the exact plot for this. Okay, so let us start. So if you check out what we have is, we will be having four probabilities, right? Let us check them. Yes, so if you see, at omega equal to 0, the magnitude that you have is half, and the angle at omega equal to 0 is nothing but minus 180 degrees, which means, see, this is minus 180 degrees, right? So here I will be having this half, right? Yes, this is the starting point, right? Now what is happening at omega equal to infinity? At omega equal to infinity, you see, magnitude is going to be 0 and angle is minus 90 degrees, which means here, this is the way. So we have seen that in such cases, it can either go like this, or it can go like this is half, or it can go like this, or it can go like this, down and then up. This is the direction, right? This can happen. By the way, these are all GH plane. Is that correct? Yes. Now see dear, so as usual, we will try to check, or we will try to eliminate some of them, right? Because at the end you have to choose only one, right? So if I try to think of if 3 and 4 are correct, let us do that, right? So if you observe this 3 and 4, if 3 and 4 has to be correct, then it means that there has to be some frequency for which the plot has angle as minus 180 degrees except half, except omega equal to 0. I mean to say, see dear, you know that this is omega equal to 0. Yes, you know that this is omega equal to 0. Yes. Now in order to check if 3 and 4 are correct, right? In order to check if 3 and 4 are correct, it means that I have to check for a frequency that if at all, a frequency exists for which the angle is minus 180 degrees, because this angle is nothing but minus 180 degrees. So if at all a frequency exists for which you have angle to be minus 180 degrees, it means that either 3 is correct or 4 is correct, right? So start with it. Let us start with it. For that, I will use angle criteria. So angle criteria is what? It is nothing but phi, which is equal to our same angle. This one, where is it? Yes, this one, the angle phase equation. So if you see, it is nothing but phi equal to tan inverse omega by 2 minus tan inverse of omega minus 180 degrees plus tan inverse of omega by 4. Right? Yes. And I know I have to equate it to minus 180 degrees because I have to check that if at all there is a frequency apart from omega equal to 0. Why? Because if you see, at omega equal to 0, you already have one intersection at minus 180 degrees axis, right? Yes. So check that. Let us check that. So if you see, let me have phase to be equal to minus 180 degrees, right? Which is equal to let me just combine these two. Let me just combine this one and this one. How to combine them? We have seen that tan inverse of A plus tan inverse of B is equal to what? It is equal to tan inverse of as A plus B upon 1 minus AB. This is what we have seen, right? 10 standard school maths, right? Yes. So by that logic, this becomes tan inverse of omega by 2 plus omega by 4. So let me write down this omega by 2 as, let us say, 0.5 omega plus omega by 4 as 0.25 omega. This is nothing but 0.25 omega, right? Yes. Now divided by 1 minus 0.5 omega into 0.25 omega. Is that correct? Yes. Now minus, let me just take this outside, minus, yes, I have this tan inverse of omega and minus 180 degrees is there. Now if you check out this minus 180 degrees on the LHS and this one on the RHS will get cancelled, right? Yes. So if you see, this becomes tan inverse of, if I add them, I get 0.75 omega upon 1 minus 0.125 omega squared, right? Now if I shift this one, this negative tan inverse of omega on the LHS, then it will become positive tan inverse of omega. Is that right? Yes. Now applying tan on both sides, what do I get then? If I apply tan on both sides, I get, because tan and tan inverse will get cancelled, so I'll get omega, which is equal to 0.75 omega upon 1 minus 0.125 omega squared, right? If I place this in my calculator, I get omega to be equal to 0 and root 2, right? This means that yes, omega equal to 0 has been already accounted for. We know that at omega equal to 0, my plot intersects minus 180 degrees axis, right? But now you have another frequency which is root 2 at which it is happening, which means this is root 2, which means this frequency is root 2 frequency. At omega equal to root 2, this is happening. At omega equal to root 1, this is not magnitude, this is frequency. At omega equal to root 2, it is there, right? Now what are you supposed to check? Because this indicates that the first and second are invalid. They are gone. Now we have a great competition between third and fourth, right? So if you think of, what will I do? I will take any frequency between omega equal to 0 and omega equal to root 2, means any frequency between these two, right? Between these two. And if I see, if I find any angle which is in this particular region or not, right? Similarly here also if you see, what will I do? I will put some frequency ranging from omega equal to 0 to omega equal to root 2, and I will check that if I have some angle which is equal to this, right? So in angle criteria, if I replace omega equal to 1, because I know that root 2 is equal to what? 1.414, right? So 1 is definitely lying between 0 and 1.414, right? Yes. So if I replace it there that way, what do I get then? I get phi, which is equal to, let us say, tan inverse of, this is omega by 2, right? This was the angle. So if I think of omega by 2, so omega is equal to 1. If I place omega equal to 1, what do I get then? I get tan inverse of half minus tan inverse of 1 minus 180 degrees plus tan inverse of 1 by 4. If I place this in calculator, the angle that I get phi is nothing but 184 degrees. 184 degrees. So if you check out, if this is minus 180 degrees, if this is minus 90 degrees, right? This is plus 90 degrees, or we can say 270 degrees, right? This means that 184 minus 184 degrees, minus 184 degrees, where does that come? Where does that come? Minus 184 degrees should come here somewhere, right? Because this is minus 180 degrees, this is minus, this axis is 180 degrees, so this has to be minus 184 degrees. So that, because this is 270, right? Yes. So 184 has to be between minus 180 degrees and minus 270 degrees. Is that correct? Yes. Right. So which means that third is correct and even fourth is wrong. So if I redraw this plot, what do I find? This way. This is real part of GH. This is imaginary part of GH. Right? We have seen that third is right, right? Which means the construction will look like this. And this point is nothing but half, right? Now if you think of, this was the step 1. Step 2 was what? Step 2 was to plot the mirror image, right? If you think of here, if you see, how is that mirror image? Because it has to be continuous as well, so this is going to be the mirror image, right? And the third step is what? Semicircles, infinite radius semicircles. If you check out the transfer function, here you have no poles or zeros at origin, which means semicircles no need, semicircles no need, right? So this is the Nyquist plot in totality. This is the second step, this was the first step, right? Yes. Now see dear, what about encirclements? If you see, half is here, half is lying here, which means somewhere around here I should be having -1, right? Yes. Now see what I'm saying, -1 should be somewhere here, means this axis, if it goes this way. So if you see, there are no encirclements around -1, there are no encirclements around -1. It indicates that encirclements n is equal to 0. Because if you see, if I, by the trick, if I check this one to be like this, then there is no intersection to it, right? Which means n is equal to 0. So now if I just replace this in our criteria, what is that? N is equal to OLP plus minus CLP plus, what is that? It is 0. What is, how much is OLP plus? If you see, you are having one pole on the right half of S plane, and this is open loop transfer function, right? Which means OLP is 1. What is CLP? Is minus CLP plus. So if I put the CLP plus here, I get closed loop pole at RH CLP plus equal to 1. What does this indicate? This indicates that you have a closed loop pole at RH, or you can say, which means that at here you have, somewhere here you have this closed loop pole, right? This means that system is unstable. System is unstable. I hope you are understanding the point. If you check out here, open loop transfer function was also unstable, and closed loop transfer function is also unstable, whereas in the previous case, if you see, open loop transfer function was unstable, but we saw that closed loop transfer function is stable. This is the thing. So by open loop transfer function, you cannot say that it is stable or unstable. The analysis has to be done, right? Now, third example. Yes. So step number 1 is what? To draw the polar plot. Step 2 is what? To draw the mirror image. Step 3 is what? To draw the semicircles. And then you have to check for encirclement. This is the way we go, right? So for starting with the polar plot, what do you need? Firstly, what you have to do, you have to write gh of j omega, right? Which means you have to replace s by j omega. So if you replace, you get j omega plus 10 the whole squared upon j omega the whole cube. Let it be that way, no problem. Now if I think of magnitude, what is magnitude? M is going to be, yes, if you see, real part plus imaginary part, right? So it is going to be under root of real part square plus imaginary part square, which is 100 plus omega squared. And yes, definitely you have the square on the top, so you have to have this square, right? Divided by what we have is omega cube. So here, how much is the magnitude for denominator? It is going to be omega cube, right? So if you think of, this becomes 100 plus omega square, because the square root and the square gets cancelled, so you get 100 plus omega squared upon omega cube. Is that correct? Yes. Now if you think of phi, phase angle phi, how much is phi? If you see, how much is phi? Phi you get, see here on top, what you have this pole 2 times. See, if you don't understand, you can just simply write it this way: gh equal to s plus 10 into s plus 10 upon s into s into s. It's okay, there is no problem, right? Now if you see the angle contribution by the first one, it is what? It is nothing but tan inverse of imaginary part by real part. Imaginary part, let me just take it j omega, j omega, j omega, j omega, j omega, right? Let me draw it in a better way. Yes, I can put it this way: j omega plus 10 into j omega plus 10 upon j omega into j omega into j omega, right? So if you think of the numerator, the first one is what? It is going to be tan inverse of omega by 10. So it becomes tan inverse of omega by 10, right? Again, if you think of next one is again the same. So you get tan inverse of omega by 10, omega by 10. So again, plus tan inverse of omega by 10. Is that right? Yes. Now minus, what is there at down? Angle contribution by the first one is 90 degrees. Angle contribution by second one is again 90 degrees. Again, angle contribution by third one is going to be minus 90 degrees. So what you get in totality is, you add them and you add them. What you get is phi equal to 2 times tan inverse of omega by 10 minus 270 degrees. I hope this is very clear, right? This is the equation. Now can you apply, now yes, the step one is what? M0, M infinity, right? So step 1 is what? To find M0 and M infinity. M0 is what? Magnitude at omega equal to 0, which is what? If you see in this equation, if I replace omega by 0, what do I get? I get 100 plus 0 upon 0, which is equal to 100 by 0, which is infinity. Then what is magnitude at infinity? It is going to be m at omega equal to infinity, which is equal to what? 100 plus infinity upon infinity. So if you see, you cannot do that, right? You just cannot do that. So you will have to take omega squared common here. So if you take omega squared common, what is there inside is 1 plus 100 by omega square. 1 plus 100 by omega square divided by omega cube is there. So if you take this omega squared and this cube, this one down, now if you replace it by infinity, this becomes infinity. If this becomes infinity, this totality becomes 0. So it is going to be 1 plus 0, which is 1 upon infinity, which is nothing but equal to 0. So m infinity is what? It is going to be 0. Now step 2 is what? Step 2 is angle. So if you think of angle, phi 0 and phi infinity. How much is phi 0? Phi 0 is what? Phi at omega equal to 0. How much is that? If you see here, this one, focus on this one. If you put omega equal to 0 in angle equation, this equation, you get 2 times tan inverse of 0 minus 270 degrees. 2 times tan inverse of 0 minus 270 degrees. What does that mean? It is going to be equal to minus 270 degrees. Is that correct? Yes. Now, if you think of phi infinity, what is phi infinity? It is phase angle at omega equal to infinity. How much is that equal to? You put, then you get tan inverse of infinity minus 270 degrees. What is tan inverse of infinity? Tan inverse of infinity is 90 degrees. So it is nothing but 2 times 90 degrees. So 2 times 90 degrees is 180 degrees minus 270 degrees, which is equal to minus 90 degrees. So phi at infinity is equal to minus 90 degrees. This is going to be the step 2. Now can I apply step 3 and step 4 for that 4-step method? Let us see. If you observe, there are no poles. If you observe in this equation, in this open loop transfer function or this loop gain, if you see, you see that there are no poles nor zeros at on the right half of S plane, which means it can be applied. So what is step 3? Step 3 is to find ending direction. What is ending direction? For ending direction, you do phi infinity minus phi 0. Phi infinity is equal to what? Phi infinity is minus 90 degrees and phi 0 is minus 270 degrees. So minus 90 degrees minus of minus 270 degrees, which is equal to what? Minus 90 degrees plus 270 degrees, which is equal to how much? Plus 180 degrees, which is positive. That means ending direction is anti-clockwise direction. I hope you are understanding this point, right? Now what is step 4? So what is step 4? Step 4 is to find the starting direction. For that, what we do is we plot the polar plot. How will that polar plot look? If you see, you have 3 poles at the origin and you have this. If you see what is happening, you have 3 poles at the origin and you have 2 zeros at s equal to minus 10, right? So you have here 2 zeros, right? And you have here 3 poles, 2 3 at origin. Is that right? Yes. Now our thing is that we ignore everything that is there on imaginary axis and on the right half, right? So if I ignore this, what do I observe? I observe that I have 0 first, 0 closer to origin, which means starting direction is, if 0 is closer to origin, which means starting direction is again anti-clockwise. Is that correct? So you get ending direction to be anti-clockwise and starting direction to be anti-clockwise. If I try to plot this, how do I get the polar plot? Let us check out. Real part of GH, imaginary axis of GH, right? Yes. Now see dear, let me write angles as well. This is 0 degrees, this is minus 90 degrees, this is minus 180 degrees, and this is minus 270 degrees. Okay. If you see, at omega equal to 0, what is happening? Magnitude is infinite and angle is minus 270 degrees. So at minus 270 degrees at omega equal to 0, which means it comes here. Is that correct? Yes. Now where does that end? Now if you check, it has to start here, right? So this is omega equal to 0, right? It has to start here. What is the starting direction? If I see, starting direction is how much? Anti-clockwise, which means starting direction has to be this way, right? Yes. Now if you think of m infinity is going to be 0 and angle at omega equal to infinity is going to be minus 90 degrees, which means 0 and this is minus 90 degrees, axis, right? Yes. So how much is the ending direction? Ending direction is going to be anti-clockwise, so this has to be anti-clockwise this way. This will end here like this in anti-clockwise direction, which means this has to join the party like this. Is that correct? Yes. So this is at omega equal to infinity, right? Yes. Now second step is what? To plot the mirror image about the real axis of GH, which means how will the mirror image look? Mirror image is going to be somehow like this. This becomes a mirror image, right? Yes. Now third step is what? Third step is to see is semicircles, right? Is semicircles. So if you check out, there are three poles at origin, which means there will be three semicircles, right? So three semicircles, how will they go? It will go like this. One semicircle, two semicircle, and three semicircle. It ends. This is the Nyquist plot, right? Yes. Now I am interested into the encirclements, right? So now encirclements about what? Encirclements about -1 plus j0. We already know. So we need to check that where this particular point comes in on this axis. We definitely know that it is on this axis only, but where it exactly comes, we need to check, right? So for this, what we will do is, let us find the magnitude at this point. Miss, what is that? See, if this point, if at this point, let me take another color. If I can somehow manage to find the magnitude at this one, at this point, what will happen at this point? Okay, what will happen? I can easily trace where my -1 plus j0 will be. How does that happen? I will tell you. Wait, see. For this, so in order to check the magnitude at this particular point, let me use angle criteria, because angle, we know angle is going to be -180 degrees. So the first thing I will do is, I will try to find the frequency at which it is happening, the frequency at which my plot intersects -180 degrees, and then the same frequency I will put in the magnitude equation, and I will try to find the magnitude here. Let us do that. So by angle criteria, if you see, I have phi equal to 2 times tan inverse of omega by 10 minus 270 degrees, right? Yes. So if I just put this phi as -180 degrees, 180 degrees is equal to 2 times tan inverse of what? Omega by 10 minus 270 degrees, right? So it becomes tan inverse of omega by 10, which is equal to 45 degrees, right? Which is equal to 45 degrees. So omega by 10 is equal to 1. Therefore you get omega equal to 10 radians per second, right? Yes. Now if I want to check the magnitude at this frequency, what will I do? I will just simply replace it in our equation. So what is that magnitude equation? It is 100 plus omega squared by omega cube at omega equal to 10. If I replace it by 10, what I get is 100 plus 10 squared, which is 100, divided by 10 cube is going to be 1000. So it is going to be 200 by 1000. 200 by 1000. Therefore magnitude is going to be 0.2, and the angle is definitely -180 degrees. So this particular point is nothing but minus 0.2, which means -1 has to be somewhere here. Is that correct? Why? Because these are infinite radius circles. These circles are infinite radius circles. So you cannot say that, sir, you please put this one here, -1 here. No, it doesn't happen that way. It cannot happen. Why? Because these are infinite radius circles, right? Now I need to check what? I need to check the how many times it has been encirclements, right? So to check that, I will just take it this way down. If I check down, what do I see? I see that this one was going anti-clockwise, so this was going this way, and this was also going this way. What do I see? I see that I have these pins which are there. These are clockwise, right? These are not anti-clockwise. If this was this way, it would have been anti-clockwise, but this is in this way, which means it is in clockwise direction. So this is clockwise, this is also clockwise, which means it is going to be -2. N is equal to -2. N circle means n is equal to -2. It means that now by stability criteria, if I put, because n is equal to -2, we know what is n. N is equal to OLP plus minus CLP plus, right? What is n? N is nothing but equal to -2, which is equal to how much is OLP plus open loop poles at RH. Are there any? No, 0. So there are no open loop poles at RH, which means this is 0. Minus CLP plus, if you see what is CLP plus, CLP plus is nothing but equal to 2. This minus minus gets cancelled, right? So there are two closed loop poles on the right half of the S plane, which means system is unstable. I hope you are understanding this point. So if you see here, see what has happened. Open loop was also unstable because there were repeated poles on the origin, and even you have got these two poles on the right half of the S plane. These are closed loop poles, right, for the closed loop system, so it is going to be unstable. So in this way we have seen some examples regarding the Nyquist stability criteria. In the immediate next session we will also see some numericals on the same. Thank you.